Everybody, it's Tyler. I'm here at the VexU Purdue Slam and Jam event. This is an incredible event, and we got an incredible team here. ZIPS1's coming in from the University of Akron from Ohio. Can't wait to talk more about this team, some of the cool stuff they're doing as well. A lot of great, interesting things. I really want you to take a look at their wall stake mech and how they're utilizing their motors here. The whole motors are actually pivoting with it, which is really cool. They got a great goal rush mech. The first match we filmed them, an awesome rush to those goals and a great fight there against Louis. It was really cool to see with that. We talked about some of their code, what's gone into as well, and some future plans in their code where they're working on an OTOS sensor, and I can't wait to learn more about how they're implementing that on their robots. Let's learn more about them coming up here on Pits and Parts. This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, drill powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected. Jacob, let's dive right into this robots on the mechanical feature side. I know you're going to give a little bit of a brief overview, but I really want to focus on how are you doing this wall stake and that go rush as well too.
Yeah, so this is our 15-inch robot. The main thing that we needed to is make sure that we were in size the whole time. So that means that we have a really stripped down robot. Like we have a 600 RPM direct drive chassis, and then everything else that we can convert to be lighter weight, we can. However, one big issue is a lot of us are used to the high school level where you have 18 inches to work around with, but since we're limited to 15, we had to get a little creative with our wall stake mechanism. One of the main things we figured out in design is we had to have a folding intake. That way we could fit within size, but also have reach with it. So that means we had to have a lot of room up here for it to fold up when we needed it to. And that gave us a unique design problem when it came to our wall stake mechanism. Because on most traditional robots, you have a completely stationary motor and a simple drivetrain that allows you to move the arms up and down. However, we realized we wouldn't be able to easily mount the motors and build a drivetrain without way overcomplicating it and making it really hard to just make simple and effective. But at one late night, we came up with a pretty simple solution. We found out that the motors don't have to be stationary relative to the robot. And we found out we can actually put them in line with the arms of our wall stake mechanism. So the creative thing that we came up with is we actually have custom 3D printed blocks in here that have a square cutout for the motors. And instead of the motors sitting, they actually pivot around the axle, which is very different. Usually we're used to axles being the rotating part, motor stationary. This time it is the complete opposite. And it's also very nice because it also makes our ports very accessible. So if we ever have a blown motor port or the wire ever comes undone, we can easily make sure that they're all working and effective. We decided to go for 2 motors on this one because we found that not only does it give us a lot of speed, but it also gives us plenty of power. So if we're having issues trying to jam the ring onto the wall stake, we can easily just force it on there.
What kind of testing did you have to do in order, when you were putting that on, did you just slap it on and say this baby's good, or what kind of went into testing to make sure it was going to be optimized correctly for you?
So originally we actually started out with 1 motor, and we were happy with the performance at first, but then we found out we actually wanted to D-score. And with the mobile goals having the rubber top on it, it's kind of hard to pull rings on it, especially if it's on the neutral stake. If you have anywhere from 1 to 3 rings that you're trying to pull off, you're going to need more motors. So instead of gearing down our motor, which would reduce our speed and also increase its complexity, we decided that we could easily fit another motor. It wouldn't be hard at all to make the adjustments, and it could easily let us D-score.
Very cool. Talking about your goal rush mech.
So our goal rush mech, we really prioritize simplicity in this entire robot, and the goal rush arm is no different. So we really didn't want to overcomplicate it. I'm gonna put it down. So we have a very simple clamp that actuates on this 25 millimeter piston, and it conforms to the shape of the goal, so it clamps down just fine. And if you put it up, you can actually see we have these little wheels underneath that conform to the bottom of the goal, and this basically just makes it so if anybody's pulling against us, that actually means that the harder they pull, the tighter of a grip we have, because it's not only pulling on this top part, but it's actually holding underneath too, and that's already proven to be very effective in our strategies in our match earlier today.
So the one thing I'll ask you, when you had in the first match, or the match we just filmed against Louis, it did look like you got there first. And you definitely had that grip.
Yeah.
They were able to pull you a little bit on that too. Do you have any future plans to maybe try to win that autonomous battle a little bit more?
Yeah. So Unfortunately, like Jacob talked about earlier, with our 600 RPM drive, that allows us to get to the goal really quickly and clamp on. But unfortunately, even though we have our 8-motor drive base underneath, 600 RPM unfortunately is still not a lot in the torque department. So for future aspirations, we definitely plan to have higher motor drive, maybe 10, maybe 12, and then a more torqued RPM, maybe 450, 480, or maybe we even look in the custom department of like 500, 520.
I do want to ask you real quick, the gears that you have in here, is this all custom work you're doing on it?
Yes, so these are all actually just PLA gears. So we took the normal Vex gears and we took the half amount of teeth. So these are normal 36 tooth gears. We took the half amount of teeth. And we did this because we noticed that with the bigger teeth, they actually meshed it together more well, allowing for a little bit less slop, which in terms of slippage and autonomous, that makes it a little bit more consistent in our autonomous.
Let's pass over to Tyler, talk more about the code on this robot here. Obviously, in VexU, autonomous is such a huge thing as you go through, but code also transcends autonomous as well, too. Walk me through what you're currently using right now.
All right, so I'm gonna start it off just really quickly. We have the basic kind of sensor setup. So on the back here, in this really tight setup, we have the inertial sensor. Obviously, if you're in Vex, you know what the inertial sensor does. Gives you the readings for obviously turning and stuff like that. Underneath, we have one horizontal odometry pod, which gets used to track our horizontal drift because we use intermotor encoders for most of our drive movements. On the 24-inch robot over here, we have both odom sensors, so we're good on that. But what I really want to focus on is kind of how we've integrated our intake in. So right now we have anti-jam techniques and color sort techniques so that whenever we're intaking, we don't usually have problems. So I'm just going to show that off real quick. Ryder's going to spin the intake real quick, and I'm going to stick a ring in here. That's the anti-jam working. So anytime a ring could get stuck, it'll just reverse really quickly for that. And then as far as color sort goes, it's in red mode right now, and we can change that in autonomous. So a red will go through really nicely, and then a blue, it just flicks it off once it hits this limit switch. And that's a lot more consistent, we found, than piston color sort. Because the piston, obviously, it's just another mechanical part. And then also it's more consistent than just going purely off of our optical sensor down here. So that's kind of how I've made our intake consistent so that we can make sure that we can just drive into really any pile of rings and just be able to intake our color only.
Overall, been very effective for us. I can't wait to see continued success from your team on that. Let's pass over to Kane and talk about some feature plans that you're looking at. We mentioned earlier in the preview, looking at doing an optical tracking odometry sensor. So I'm very excited to hear more about that and how that's going to be implemented on your robot.
Gotcha, thank you. Yeah, so all of us we're a new team. Jacob helped us start this team this year at VexU, but we all have experience in high school. And most teams in high school, if you want an odometry system to track your robot around the field and help improve your autonomous, a lot of teams use tracking wheels here that have rotation sensors on them. Essentially, combine these with an IMU to track the heading, and that kind of lets you localize your robot on the field. But as you can see, it's very bulky, and another big issue is these wheels can have some slippage, which can cause inconsistencies. So one thing I was really excited going into VexU is using some of my electrical engineering knowledge going into my third year and incorporating some additional electronics. So we found this neat sensor from SparkFun that a lot of the FTC teams are starting to use. Essentially, this 1-inch by 1-inch sensor will replace both tracking wheels and the IMU on our robot. And the way it works is on the top there is a 6-axis IMU unit, and then on the bottom is a laser sensor. So essentially that works the same as your computer mouse, and it tracks the X and Y position. So really excited to get it implemented to Worlds. We're also using a Raspberry Pi Pico as our co-processor. So essentially what this does is it takes in the sensor data, processes it, sends packets to the brain, and then we incorporate it into our code from there.
Can you, in a really brief way, can you just describe what it's like to actually code something like that? Like, what are you getting in terms of feedback, and how are you implementing your code that way then?
Yeah, so essentially, it's simple just going from the OTA sensor to the Raspberry Pi. It just sends X value, Y value, and a heading. But the real challenge comes when you have to communicate between the Raspberry Pi and the Vex V5 brain. So the way we do that is we use what's called a RS485 to TTL converter. What this does is it translates the logic levels because they use 2 different communication methods. So what we have to do is encode the data on the Raspberry Pi into packets with a specific structure, send that to the V5 brain, and then our C++ code there will receive the packets, decode them, and then implement it into our autonomous routine.
Really great stuff that's gone in all the way from the mechanical to the electrical and software side of things. So ZIPS1, thank you so much for taking time to tell us more about your robot. Wish you best of luck here, of course, as well too, but as you hopefully continue your journey in the VEX roles and even beyond. So appreciate it, especially as a new team coming through. Welcome to the community and can't wait to see what you do in the future. Thanks a lot.
Thank you.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected.